The lining of your stomach holds back acid strong enough to break down the meat in your meal, yet it isn't burned away, and renewal is the trick. The cells facing that acid are sacrificial. They live only a few days before the acid and enzymes wear them down, so the stomach replaces lining roughly every few days. Stem cells in the deeper folds churn out fresh cells that migrate up to the firing line. A thick coat of mucus buys each cell a little time, but the real defense is speed of replacement. The wall survives its own acid not by being tough, but by being constantly. When a whale dies, it sinks and becomes a town. A carcass landing on the deep sea floor can feed a feast that lasts for decades. First, scavengers strip the flesh, then worms and snails work the bones. Finally, bacteria break down the fats locked inside the skeleton, releasing chemicals that other microbes turn into food. And a whole community blooms in the dark with no sunlight at all. A single death seeds an oasis of life in the empty deep. One slow funeral feeding hundreds of species. Drop below a few hundred meters and the color red simply ceases to exist. Water absorbs red light first, so by these depths, there is none left to reflect. This is why so many deep-sea animals are colored deep red, even though it looks like vivid scarlet at the surface. With no red light to bounce off them, they appear utterly black down here, hidden from predators. Their bright color is, in the dark, the most perfect camouflage there is. Before paper reached them, the Maya recorded their calendars on folded screens of tree bark, painted in bright colors and read like an accordion. Their timekeeping was built from interlocking cycles, one of 260 days, one of 365, meshing like gears. The two only realign after about 52 years, a span they treated as a kind of century. This let them track immense stretches of time precisely, because combining two cycles of different length creates a much longer one before the pattern repeats. Counting time for them meant watching wheels within wheels turn. Plutarch said the mind is not a vessel to be filled, but wood to be kindled. The difference is everything. A full cup only holds. A lit log makes more light than it was given. Teaching, then, is less pouring than sparking. The first ecosystems found around deep-sea vents overturned. Frost can form on a clear night even when the air never drops to freezing. The trick is radiation. On a cloudless night, the ground beams its heat straight out to the cold of space, with no clouds to bounce it back. The surface itself chills below freezing, while the air a meter higher stays milder. Water vapor touching that frozen surface skips the liquid stage entirely and turns straight into ice crystals. That is why frost coats the grass and car roofs, but spares the air around them, and why a single cloudy night can save a harvest. The Sahara was once green, dotted with lakes and grazing herds, and the trigger was a wobble in Earth's tilt. Our planet slowly changes how it leans toward the sun over thousands of years. A few thousand years ago, that lean pulled summer rains farther north, and monsoon storms watered what is now pure sand. Rock paintings there still show hippos and cattle where no water flows today. Then the tilt drifted back, the rains retreated south, and the green dried to dune. The desert is not permanent, it is one phase of a long, slow breathing. Life may not have needed warmth to begin. It may have needed ice. In freezing water, growing ice crystals push dissolved molecules into shrinking pockets of liquid between them, crowding them together far more tightly than open water ever could. That crowding can drive fragile molecules to join into longer chains that would never form when dilute. So cold, usually the enemy of chemistry, might have acted as a concentrator. The reactions that started life could have been squeezed into being inside the spaces left by freezing. Inside a dying, massive star, the elements arrange themselves like the layers of an onion. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. It is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. Under anesthesia, you may feel that no time passed at all. A property surgery and ordinary sleep do not share. After deep sleep, you sense hours elapsed. After anesthesia, the gap can feel instantaneous, as if the world jumped. The clue is in what the drugs disrupt, the integrated brain activity thought to underpin continuous experience. Without that ongoing integration, there is no stream to lay down, no felt duration, perhaps a teaspoon of black hole, if you could scoop one, would not have a fixed weight, because a black hole's density depends entirely on its size. Small ones are almost unthinkably dense, but the supermassive giants are different. Spread their enormous mass across their enormous horizon, and the average density can fall below that of water. You could not float one in a glass, of course. The point is subtler. Bigger holes pack their mass so loosely that the space inside the horizon is mostly, by ordinary measures, sparse. Density and darkness are not the same thing. Spin a turbine in a power plant, and you are really just shaking magnets and coils against each other. Water, steam, or wind turns a shaft. The shaft whirls magnets past loops of wire, and the ceaseless change of magnetic field pushes. It is wise to hearken, not to me, but to the Word, and to confess that all things are one. Heraclitus called the underlying law the Logos, and asked us to trust it over any speaker, himself included. Physics took the dare seriously. The same handful of laws that bend an apple's fall also steer a galaxy. One rule, indifferent to scale, binding the small and the immense into a single account. Dreams come most vividly in a strange state called REM sleep, when the eyes dart beneath closed lids and the brain blazes nearly as bright as waking. Yet the body lies paralyzed. A switch in the brainstem releases chemicals that silence the spinal cord, cutting the link between intention and muscle. So you can run in a dream and never leave the bed. This lock is protective. When it fails, sleepers act out their dreams, kicking and shouting at enemies only they can see. Some stars you admire tonight may no longer exist. Light from a distant sun can take thousands of years to cross the gap to Earth. If such a star burned out a millennium ago, its final light is still in transit, still painting a point on your sky. You would go on seeing it shine faithfully until that last wave of light swept past. The star is gone, but its image lingers, a candle whose flame we still watch long after the wick is cold. A living cell is mostly a bag, a thin, oily film holding the inside apart from the outside. And here's the surprise. That bag can form by itself. Certain fatty molecules dropped into water automatically arrange into hollow spheres because one end of each molecule loves water and the other end flees it. Trapped between those preferences, they curl into a closed wall with no help at all. So one of life's defining features, the boundary, isn't an invention. It's what these molecules do naturally the moment they meet water. Lightning can strike the ground some distance from where you stand and still reach you, through your feet. When the bolt hits the soil, current spreads outward and the ground itself develops a voltage that falls off with distance. If your feet are apart, one stands at a higher voltage than the other, and that difference can drive current up one leg and down the other. This is why animals in open fields are vulnerable. Their long bodies span a wide gap, and why keeping your feet close together lowers the danger. Black holes come in wildly different scales, yet all obey one rule. Shrink any mass below a certain radius and it becomes one. For the sun, that radius is about 3 kilometers. For the Earth, a marble. For a mountain, smaller than an atom. The threshold is the point where gravity overwhelms every force that resists it and collapse turns unstoppable. So a black hole is not a special kind of stuff. It is any matter squeezed past its own limit. The recipe is universal. Only nature rarely musters the crushing pressure. You can sometimes see exactly how far the ground jumped by looking at a fence. When a fault ruptures the surface, anything crossing it, a wall, a row of crops, a stream channel, gets sheared in two and offset by the slip. Geologists measure these breaks right after a quake to learn how much of the fault moved and where. Older offsets, healed and weathered, record past ruptures along the same line. The land keeps a tally of every jump, and reading it reveals how often this fault tends to wake. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world. Type Ia supernovae explode with such consistent brightness that astronomers use them as cosmic measuring sticks. The reason lies in their trigger. Each begins as a white dwarf that pulls matter from a companion until it nears that universal mass ceiling. Reaching the same critical point, the stars detonate with nearly the same energy every time. Because we know their true brightness, comparing it to how faint they appear reveals their distance, letting us map the scale of the universe. We can count back through history, but our years have no year zero. The calendar most of the world shares jumps straight from 1 year before a chosen point to 1 year after, with nothing between. This is because it was designed long before zero was treated as a number you could place on a line. To its makers, you counted 1, 2, 3, the way you count anything real, and you do not start counting at nothing. That missing zero is a fossil, a trace of an age when the idea of nothing had not yet found its place among the numbers. When a giant star dies, its core collapses in less than a second, falling inward at a quarter the speed of light. The infouling matter slams into the newborn neutron core and rebounds, and a flood of ghostly particles called neutrinos pours outward. Almost all of them pass straight through the star, but enough push back to blow the outer layers apart. That rebound and neutrino blast is a supernova, briefly outshining an entire galaxy of 100 billion stars. Deserts can be plotted not just by latitude, but by distance from the sea. Air loses its moisture as it travels inland, raining it out along the way. Push deep enough into the middle of a large continent, far from any ocean, and the wind arriving there has already been wrung dry. Central Asia holds vast deserts for exactly this reason. The sea is simply too far. The farther moisture has to march over land, the less of it survives the journey. Distance alone can starve a land of rain. Spin a bucket of water fast in a vertical circle and not a drop falls out, even when it is upside down overhead. The water is not held by the bucket's bottom, but by its own motion. It wants to fly off in a straight line. The bucket's base curves into its path and forces it to turn. As long as you swing fast A teaspoon of fertile dust from one desert can feed a rainforest an ocean away. Wind lifts fine mineral particles off dried lake beds in places like the Sahara and carries them thousands of kilometers across the sea, high in the air. When that dust finally settles over distant jungles, it delivers phosphorus and iron that heavy rains have long washed out of tropical soils. So the greenest forests can lean, in part, on the driest land on Earth. Two opposite worlds are stitched together by a river of airborne grit. Montaigne kept returning to one quiet aim. The greatest thing in the world, he wrote, is to know how to belong to oneself, not to rule others, not to gather more, but to own the one mind that is actually yours. Self-possession, he thought, is the rarest wealth. Alone in a sky this empty, the traveler has nothing to belong to but himself. And that, Montaigne would say, is enough. Most of the helium and carbon you encounter began inside stars through a process of patient assembly. In stellar cores, hydrogen nuclei fuse into helium, and in older stars, 3 helium nuclei collide to form carbon. This stepwise building of heavier elements from lighter ones is how the cosmos grew chemically rich. The earliest universe held almost nothing but hydrogen and helium. Everything more complex, including the carbon in every living thing, was manufactured by generations of stars. The sun you see is always 8 minutes and 20 seconds old. Sunlight isn't instant. It crosses 93 million miles of empty space at a fixed speed, and that journey takes about 500 seconds. So the bright disk in the sky shows where the sun was, not where it is. If it somehow vanished, Earth would keep orbiting a ghost, bathed in warmth from a star already gone, until the news arrived at the speed of light. Every glance upward is a glance into the recent past. Some caves hold pools rimmed by stone dams, terraces of water stacked like rice paddies. These rimstone dams build themselves. As a thin sheet of mineral-laden water flows across the floor and spills over a lip, it speeds up and churns slightly at the edge. That turbulence drives off carbon dioxide faster there, so calcite is deposited most heavily right along the rim. The growing edge traps more water behind it, which raises the rim higher still. The cave engineers its own dams, each one a place where flowing water shed its mineral fastest. When an ocean plate dives beneath a continent, it does not melt the way you might expect. Heat alone is not enough at those depths because the rock is under crushing pressure. What triggers the melting is water. The sinking slab carries seawater locked inside its minerals, and as it descends, that water is squeezed out into the hot rock above. Water lowers rock's melting point dramatically, does not switch the brain off. In dreaming sleep, parts of it can run hotter than waking. Brain activity surges, the visual and emotional regions blaze, while the regions that anchor logic and self-monitoring go quiet. That imbalance explains the texture of dreams, vivid and emotionally charged, yet weirdly accepting of impossibility. You fly, or a stranger is somehow your sister, and you don't question it because the part that would object is dimmed. Dreaming is not less brain activity, it is the same machinery running with different parts in charge. A clownfish lives inside a wall of poison and calls it home. The sea anemone's tentacles fire stinging harpoons that paralyze most fish on contact. But the clownfish coats itself in a mucus the anemone reads as part of its own body, so it never fires. Safe inside, the clownfish drives off the anemone's predators and drops scraps of food. The deadliest thing on that stretch of reef becomes a fortress, opened by a chemical password the fish learn to forge. Some of the oldest long-distance trade carried a bluestone. Lapis lazuli, prized for its deep color, came mostly from a few remote mountain mines and ended up in ornaments thousands of kilometers away. It traveled so far because little else looked like it, and the richest source lay in one hard-to-reach valley. Long before any unified road, the demand for that color stitched together a chain of traders, each passing the stone onward. Beauty that could be dug from almost nowhere else pulled a road into existence. Imagine watching the universe's history run in reverse. Galaxies racing together, starlight pouring back into suns. Nothing in the fundamental equations forbids this film. What forbids it is the beginning. The cosmos started in a state of remarkably low disorder, and it has been spreading toward higher disorder ever since. That single initial condition, not any law of motion, sets the direction of every clock. Why the beginning was so orderly, no one knows. It is among the deepest open questions in physics. The arrow you feel pointing from birth to death traces all the way back. A white dwarf the size of Earth can be hotter than the surface of the sun, yet it produces no energy at all. The heat is left over. Having ceased all fusion, a white dwarf is simply the exposed, glowing core of a dead star, cooling like an iron pulled from a forge. Because it is so small and dense, it radiates that stored warmth slowly. The faintest, coolest of these embers have been cooling for nearly the entire age of the universe and have barely gone dark. Spend time near a black hole and you return to a future. Because gravity slows time, a person orbiting close to the horizon ages more slowly than one far away. Years for them might be decades for everyone else. This is no thought experiment. The same effect, far gentler, is measured on satellites whose clocks run faster than clocks on the ground. Deepen the gravity and the gap widens without bound. Near a black hole, patience becomes a kind of time travel. Slow your own clock against the universe, and the cosmos races ahead while you barely move. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. He who should teach men to die would at the same time teach them to live. Montaigne wrote that and meant it plainly. To rehearse your ending is not morbid. It sharpens the hours you still hold. The figure adrift here is doing exactly that rehearsal, falling with eyes open. Knowing the fall has a floor somewhere below is what makes the drifting worth watching. On a heaving deck, a sailor could not write fast enough to track every change of course, so he poked holes in a board. The traverse board was a wooden disc carrying a compass rose, with a peg pushed into a hole for each half hour to record the headings sailed. Below, more pegs logged the speed. At watch's end, the pattern of holes told the whole story of the last 4 hours. Which way, how fast, how long. It let an unlettered crew keep flawing. Cut a magnet in half, hoping to separate its north pole from its south, and you fail. Each half becomes a smaller, complete magnet with both poles again. Cut those and the same thing happens, down to the level of single atoms. The reason is that magnetism comes from the circling and spinning of charges, and a circle has no end to isolate. Every loop of moving charge carries both poles at once, inseparably. You cannot hold a lone north pole because magnetism is not made of separate charges, but of motion that always loops back on its. A neutron star can spin hundreds of times every second, faster than a kitchen blender, while holding more mass than the sun. The speed is a consequence of collapse, a slowly rotating stellar core shrinking from a width of 1,000,000 kilometers to barely 20, must spin up dramatically to conserve its rotational motion. The surface of the fastest of these whirls at a sizable fraction of the speed of light. Yet the star stays intact because its gravity is almost unimaginably strong. A system of numbers traveled farther than any army. The way of writing numbers with a place for zero arose in India and moved west through trading and scholarly hands, because merchants doing accounts everywhere felt how much easier it made calculation. A method spreads when it solves a problem people already have. Ledgers, interest, and long sums all grew simpler with these symbols, so the symbols stuck. No conquest carried them. The plain usefulness of counting did. When a giant star dies, its core collapses in less than a second, falling inward at 1/4 the speed of light. The unfouling matter slams into the newborn neutron core and rebounds, and a flood of ghostly particles called neutrinos pours outward. Almost all of them pass straight through the star, but enough push back to blow the outer layers apart. That rebound and neutrino blast is a supernova, briefly outshining an entire galaxy of 100 billion stars. The calcium in your bones and the iron in your blood were cooked inside stars that died before the sun was born. Lighter elements like carbon and oxygen form in the fusion furnaces of aging stars. Heavier ones are scattered when those stars explode, seeding clouds of gas with fresh ingredients. From such enriched clouds, new stars and planets form. You are quite literally assembled from the ash of earlier stellar deaths, a fact that links your body to events billions of years gone. Some black holes fire jets of matter across distances larger than the galaxies that host them. Gas spiraling inward gets caught in twisted magnetic fields near the spinning hole, and instead of falling, part of it is flung outward along the spin axis at nearly light speed. These beams can stretch for thousands of light years, lighting up in radio waves. It is a paradox in plain sight. The most efficient trap in the universe is also one of its great launchers. What the whole cannot swallow, it hurls back into the dark with astonishing force. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns Drop a pebble in a still pond, and ripples spread outward in neat circles. You will never see ripples converge inward and spit out a pebble, though the wave equations permit exactly that. This is the arrow of radiation, another face of time's direction. The outgoing wave is favored not by law, but by setup. It is staggeringly hard to arrange the precise inward motion the reverse would require. So waves, like heat in broken glass, run one way for the same statistical reason. Everywhere we look, time's flow turns out to be improbability. There is brine so concentrated that it forms lakes at the bottom of the sea, pooling on the seafloor with a visible shoreline 1 kilometer underwater. These brine pools are several times saltier than the ocean around them, and salt makes water heavier, so the brine sinks and refuses to mix. It lies in hollows like syrup in a dish, with waves that lap against a true edge. Fish that blunder in can be pickled by the salt. An ocean inside the ocean. There is a sphere of galaxies we could still send a message to, and beyond it, a vast realm we never can. Because the recession grows with distance, past a certain range, galaxies pull away faster than light can travel toward them. Any signal we send simply cannot keep up. That boundary marks the limit of everything we could ever touch, hear, or influence. Marcus Aurelius turned his attention to the elements as a kind of cure. Constantly consider the changes of the elements into one another, he wrote. Watching matter become matter without end. Earth into water, water into air. Nothing destroyed, only rearranged. Seen this way, an ending is just a handoff. The same atoms move on. The figure falling here belongs to that endless exchange, never lost, only passing into the next form. Coral reefs are built by animals that farm the sun. The living coral is a thin skin of tiny polyps, but each polyp gardens algae inside its cells, and those algae need light. That single requirement explains the architecture of an entire ecosystem. Reefs grow only in clear, shallow, sunlit water, and they build upward, racing the rising sea to stay in the bright zone. The vast limestone ramparts that shelter roughly a quarter of marine species are, at heart, a structure built to hold algae up to the light. Inside a dying, massive star, the elements arrange themselves like the layers of an onion. The reason is temperature. The core is hottest, so it fuses the heaviest fuels, building up to iron at the center. Surrounding shells, each cooler than the one within, fuse progressively lighter elements. Silicon, oxygen, carbon, helium, hydrogen at the outside. The star burns through these layers in a desperate, accelerating sequence. The final stages lasting mere days before the core gives way and collapses. A wind-carved desert rock can stand wide on top and pinch thin below, like a stone mushroom. The sculptor is sand, but it only flies so high. Wind lifts grains and bounces them along, yet most of that blasting sand travels within about a meter of the ground. So the lower part of a boulder gets sand-blasted hardest. Worn back faster than the top, the grains cannot reach. Over ages, the base narrows while the cap survives. The shape is a record of exactly how high the desert's grit can leap. Light cannot escape a black hole, yet black holes can shine brighter than whole galaxies. The trick is what happens just outside. Gas spiraling inward piles into a flat, whirling disk, rubbing against itself at near light speed. Friction heats it to millions of degrees, and that searing gas blazes across the sky. The light never comes from inside the horizon. It comes from matter screaming on its way down. So the darkest objects in the cosmos announce themselves with the brightest beacons, fueled not by what falls in, but by the divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Color is not a property of light. Light has only wavelength, redness, blueness, the warmth of gold. Those are inventions of the brain. three kinds of cone cells in the eye each respond to a band of wavelengths, and the brain compares their signals to assign a color. That's why two completely different mixes of light can look identical, and why the same surface can read as one color in shade and another in sun until the brain corrects it. The rainbow you see isn't out in the rain. It's the brain's code for energy your eyes can't otherwise tell apart. A supernova can briefly release more energy than the sun will emit across its entire 10 billion year lifetime. The source is gravitational collapse. When a massive core falls inward, an immense store of gravitational energy is suddenly liberated, most of it carried away by neutrinos in seconds. Only a small fraction becomes visible light, yet even that sliver can outshine a whole galaxy. For a few weeks, a single exploding star can be seen across vast stretches of the universe. Lightning does not pick its path all at once. A faint channel called a step leader gropes downward from the cloud in jerky jumps, each a few tens of meters long, branching as it hunts for the easiest route through the air. When one branch nears the ground, an upward spark leaps to meet it. Only when they touch does the main stroke flash back up the completed channel. So the dazzling bolt you see travels from the ground to the sky, retracing a path that was already scouted in the dark, millisecond by millisecond. Every black hole spins, and a spinning one drags space around with it. Picture honey stirred by a spoon. The fluid near the spoon is pulled into the swirl whether it wants to or not. Near a rotating black hole, space itself is forced to rotate. Nothing can stand still there. Not even light can resist being swept along. This region, called the ergosphere, lies just outside the true point of no return. Inside it, you could still escape, but only by moving with the spin. The hole does not merely hold space, it winds it, like thread on a turning spin. In a boreal forest, the soil itself is a slow refrigerator. Beneath the moss in far northern woods, the ground can stay frozen year-round, a layer called permafrost. The trees help insulate it. Their shade and the thick, spongy moss blocks summer heat from reaching down, while the long, bitter winters chill the earth deeply. Locked in that frozen ground is the carbon of ancient plants that never fully rotted, held in cold storage for thousands of years. The forest and the frost keep each other, each preserving the other's stillness. The calcium in your bones and the iron in your blood were cooked inside stars that died before the sun was born. Lighter elements like carbon and oxygen form in the fusion furnaces of aging stars. Heavier ones are scattered when those stars explode, seeding clouds of gas with fresh ingredients. From such enriched clouds, new stars and planets form. You are quite literally assembled from the ash of earlier stellar deaths, a fact that links your body to events billions of years gone. Spend time near a black hole and you return to a future. Because gravity slows time, a person orbiting close to the horizon ages more slowly than one far away. Years for them might be decades for everyone else. This is no thought experiment. The same effect, far gentler, is measured on satellites whose clocks run faster than clocks on the ground. Deepen the gravity and the gap widens without bound. Near a black hole, patience becomes a kind of time travel. Slow your own clock against the universe, and the cosmos races ahead while you barely move. The matter spiraling into a black hole releases energy far more efficiently than the fusion that powers stars. As gas falls through the steep gravity, it surrenders a large fraction of its mass as a pure radiation, a much greater share than burning hydrogen ever yields. That is why feeding black holes shine so fiercely. The light is the toll matter pays to fall in. Deep gravity wells convert mass into energy with brutal effectiveness. Pound for pound, nothing lights the cosmos more economically than something simply falling toward a place it can never leave. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace. Your immune system spends much of its time learning not to attack you. As immune cells mature, they're tested against the body's own molecules, and those that react too strongly to self are destroyed or silenced before release. This screening happens largely in the thymus, an organ behind the breastbone. The danger isn't only outside. A defense powerful enough to kill invaders could turn inward. So the body trains restraint as carefully as aggression, deleting its own overeager soldiers to keep the peace within. Epicurus had a strange comfort for anyone afraid of the end. A right understanding that death is nothing, he wrote, makes the mortality of life enjoyable, not by adding to life unlimited time, but by taking away the yearning for immortality. The relief is not more hours, it is the end of wanting endless ones. Out here, drifting without a clock, that hunger has nothing left to feed on. There is no single secret to surviving total dryness, but there is a common one. Replace water with sugar. Living cells are scaffolded by water that cradles every protein and membrane. Remove it and the structures collapse. Many survivors flood themselves with trehalose, a sugar whose molecules slot into the gaps water leaves, holding the architecture in place and setting into a glassy solid. In that frozen glass, nothing can move or react or rot. It is suspended animation written in chemistry. The same trick borrowed independent. Beneath a forest floor runs a network far older than any nation. Fungal threads weave themselves into tree roots, and in exchange for sugar, the fungus delivers water and minerals the roots could never reach. The threads are finer than roots and slip into spaces too small for them. One spoonful of forest soil can hold kilometers of this fungal filament. The tree feeds the fungus light turned into sugar. The fungus feeds the tree the buried earth. Neither thrives as well alone, and so two kingdoms quietly help keep each other alive. Each night, a vast crowd of small ocean animals rises hundreds of meters toward the surface, then sinks again at dawn. By sheer numbers, it is among the largest movements of living things on the planet, repeated every single day. They climb in darkness to feed on the rich surface waters and retreat to the deep by day to hide from hunters that need light to see. Fear of being eaten drives this daily commute, an ocean breathing up and down with the turning of the sun. Take apart a living cell, and you find no single component that is itself alive. The membrane is just oily molecules. The genes are just chemistry. The proteins are folded chains following physics. Life isn't located in any one piece. It appears only when the pieces work together as a self-sustaining whole. Biologists call this emergence a property that exists for the system but not for its parts. It means the question, what is the living ingredient, may have no answer because being alive was never a substance. It is an arrangement. We can study the universe's baby picture, taken before a single star was born. The oldest light comes from an era with no galaxies, no stars, only a glowing fog of hydrogen and helium. That light has crossed nearly the entire history of the cosmos. A tiny black insect leaps across snow without freezing, even in deep cold. Inside the snow flea runs a protein unlike the antifreeze of fish, rich in the simple amino acid glycine, folded to present a flat face that ice cannot easily build upon. It binds to budding crystals and stalls them before they spread. What makes it remarkable is its fragility to heat. It works best in the cold and falls apart when warm, perfectly tuned for a life lived on the surface of winter. An animal at home in a world that would freeze almost anything else. A pigeon released far from home will usually fly straight back, even across land it has never crossed. For a long time, the magnetic sense was the favored explanation, but block a pigeon's nose and its homing falls apart. The birds appear to build a map of smells, learning which odors arrive on which winds near the loft. Carried somewhere new, a pigeon samples the local air, matches it against that remembered chart, and infers the way home. It is finding its house not by looking, but by smelling which direction the world should be. The taste of your tongue is rebuilt on a schedule. Each taste bud holds a cluster of sensing cells, and those cells are surprisingly short-lived, many lasting only a week or two before they die and are replaced. New cells arise from a reserve pool at the base of the bud and mature into working sensors. This is why a scald from hot coffee dulls taste for only a few days. The burned cells are simply swapped out and flavor returns. Your sense of taste is not a fixed instrument. It is a population of cells in constant turnover. The whole tasting apparatus quietly renewing itself. Saturn's rings look like solid sheets, but they are made of countless separate pieces of ice, most no bigger than a snowball, a few as large as houses. Each fragment is its own tiny moon, following its own orbit around the planet. They cannot gather into a single large moon because they sit too close to Saturn, where the planet's gravity pulls harder on the near side of any growing clump than on the far side, stretching it apart faster than it can hold together. So the ring endures as a frozen swarm, billions of orbits that never combine. supernova can briefly release more energy than the sun will emit across its entire 10 billion year lifetime. The source is gravitational collapse. When a massive core falls inward, an immense store of gravitational energy is suddenly liberated, most of it carried away by neutrinos in seconds. Only a small fraction becomes visible light, yet even that sliver can outshine a whole galaxy. For a few weeks, a single exploding star can be seen across vast stretches of the universe. He who fights with monsters should look to it that he himself does not become a monster. And when you gaze long into an abyss, the abyss also gazes into you. Mercury swings closer to and farther from the sun than any other planet, and its surface keeps a strange record of it. Sunlit ground there can climb past 400 degrees Celsius, hot enough to melt lead, while shadowed craters at the poles hold ice that never melts. With almost no atmosphere to move heat around, each spot is left to the mercy of sunlight alone. Blazing day and frozen dark sit side by side, separated by nothing more than the edge of a shadow. The moon's glow reaches you about 1 1/4 seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. Most of the helium and carbon you encounter began inside stars through a process of patient assembly. In stellar cores, hydrogen nuclei fuse into helium, and in older stars, 3 helium nuclei collide to form carbon. This stepwise building of heavier elements from lighter ones is how the cosmos grew chemically rich. The earliest universe held almost nothing but hydrogen and helium. Everything more complex, including the carbon in every living thing, was manufactured by generations of stars. Some acacia trees in Africa hire armies and pay them in room and board. The tree grows hollow, swollen thorns and drips sugary nectar, and in return, aggressive ants move in. The ants swarm any animal that bites the leaves and even prune away rival plants that crowd their tree. Strip the ants away, and the defenseless acacia is quickly chewed back. The thorns were never just armor. They are barracks, and the tree's true defense is a standing army it feeds every single day. There is a hard ceiling on how heavy a white dwarf can be, roughly 1 4/10 times the mass of the sun. Push past it, and the star cannot survive. White dwarfs are held up by the pressure of densely packed electrons, but that support has a limit. Add too much mass, and the electrons are forced to move near light speed. where they can resist no further. Gravity wins and the star either collapses or detonates as a brilliant, oddly uniform kind of supernova. Before clocks could cross an ocean, sailors solved navigation by cheating on half the problem. Longitude, your east-west position, needs precise time, which no sea clock could yet keep. But latitude needs only a star's height, which any steady hand could measure. So captains sailed north or south until the pole star sat at the right angle for their destination, then turned and held that latitude, running due east or west until landfall. It was slower and exposed to more weather, but it traded an impossible measurement for an easy one, and it worked. Our sun will not explode. It will quietly shrink into a white dwarf, an ember the size of Earth holding nearly half the sun's mass. The reason is mass. Only stars far heavier collapse violently. When the sun exhausts its fuel, it sheds its outer layers and leaves behind its dense core. No more fusion holds it up. Instead, a quantum rule, the pressure of tightly packed electrons refusing to share the same state, props it against gravity. It will simply cool, fading over billions of years. Boil water and most life dies. Yet in volcanic vents on the deep sea floor, microbes thrive above the normal boiling point. They don't boil only because the crushing pressure down there keeps the water liquid. These heat lovers rebuild their proteins with extra internal bonds and tougher amino acid packing, so the molecules hold their shape where ours would unravel. Heat kills by shaking proteins apart until they tangle. These cells simply build sturdier proteins. The lesson drifting up from the dark, the temperatures we call lethal are only lethal inside a dying massive star. The elements arrange themselves like the layers of an onion. The reason is temperature. The core is hottest, so it fuses the heaviest fuels, building up to iron at the center. Surrounding shells, each cooler than the one within, fuse progressively lighter elements. Silicon, oxygen, carbon, helium, hydrogen at the outside. The star burns through these layers in a desperate, accelerating sequence. The final stages lasting mere days before the core gives way and collapses. Send a probe falling into a black hole, and from a safe distance, it never seems to arrive. Its light stretches and dims as it nears the horizon, and the image slows, reddens, and finally fades, appearing frozen just shy of the edge for all time. From the probe's own view, the crossing is quick and uneventful. It sweeps past the boundary in moments. Both pictures are correct. Gravity stretches the light's wavelength and stalls the signal so severely that the distant observer's clock and the falling probe's clock can no longer agree on a simple question: when did it fall in? A particular kind of exploding star always detonates with nearly the same brilliance, and that makes it a cosmic yardstick. These stars ignite only when a dead stellar core crosses a fixed mass threshold, so each blast releases a similar burst of light. Knowing the true output, astronomers read the apparent faintness to gauge enormous distances, measuring the reach of the universe one explosion at a time. Wrap a wire into a coil and run current through it, and the loose iron nail it surrounds becomes a magnet you can switch off. Each loop of the coil adds its magnetic field to the next, and stacked together they make a strong, directed field down the core. The iron amplifies it, its domains snapping into line with the coil's field. Cut the current and the field vanishes, and the iron mostly forgets. This electromagnet is how scrapyards lift cars and let them go with the flick of a switch. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. The matter spiraling into a black hole releases energy far more efficiently than the fusion that powers stars. As gas falls through the steep gravity, it surrenders a large fraction of its mass as a pure radiation, a much greater share than burning hydrogen ever yields. That is why feeding black holes shine so fiercely. The light is the toll matter pays to fall in. Deep gravity wells convert mass into energy with brutal. Two ears let you locate a sound by timing. A noise off to your left reaches the left ear a fraction of a millisecond before the right, and the brain measures that gap, as small as 10 millionths of a second, to point toward the source. For higher pitches, it also weighs which ear hears it louder, since your head casts a sound shadow. Close one ear and the world flattens. You can still hear, but you lose the stereo math that tells direction. Locating sound is arithmetic done in the dark. The wavy, watered patterns on old Damascus blades were never just decoration. The smiths worked imported ingots of crucible steel, what's melted in sealed clay pots so the iron took in carbon evenly. As the metal cooled slowly, hard carbide particles lined up into faint bands, guided by traces of elements like vanadium in the ore. Forge and etch the blade, and those bands surface as flowing rivers across the steel. Beneath a forest floor runs a network far older than any nation. Fungal threads weave themselves into tree roots, and in exchange for sugar, the fungus delivers water and minerals the roots could never reach. The threads are finer than roots and slip into spaces too small for them. One spoonful of forest soil can hold kilometers of this fungal filament. The tree feeds the fungus light turned into sugar. The fungus feeds the tree the buried earth. Neither thrives as well alone, and so two kingdoms quietly help keep each other alive. Earth holds on to its air for a reason most worlds can't claim. A gas molecule escapes to space only if it moves faster than escape velocity, and that speed depends on a planet's gravity. Earth is massive enough that its pull keeps even light, fast oxygen and nitrogen bound to the surface. A smaller world like Mars couldn't, and let most of its atmosphere leak away over ages. Your sky exists because the ground beneath it is heavy enough to keep tugging the air back down, molecule by molecule. Happiness depends upon ourselves. Aristotle builds his entire ethics toward this in the Nicomachean Ethics. Happiness for him is not luck or pleasure, but eudaimonia, living well by acting in accord with reason and virtue over a whole life. Because it rests on how you act and not on what befalls you, it lies largely in your hands. Not a feeling that arrives, but a life that is practiced into being. Float in the Dead Sea and you cannot sink, no matter how hard you try. The reason is buoyancy doing arithmetic. Ordinary seawater is about 3 or 4% salt. This water is roughly 10 times saltier, packed with dissolved minerals until it is far denser than your body. A floating object displaces its own weight in fluid, and dense fluid means you only need to push aside a little to be held up. So you bob like a cork, chest and knees in the air. The water is simply too heavy to let you go under. A protostar shines long before it becomes a true star, but not from fusion. As a collapsing cloud falls inward, gravity does work on the gas, and that infall heats the core simply by compression, the way a bike pump warms when you press it. The young object glows red and swollen on this borrowed heat alone for hundreds of thousands of years. Only when the core finally crosses 10 million degrees does hydrogen fusion switch on. Until that spark, a baby star is lit purely by the energy of its own falling. Most of the atoms in your body were forged inside stars and scattered by their deaths into clouds like the ones we drift past. Carbon, oxygen, iron, none of them existed when the universe began. They were cooked in stellar cores, then flung outward when those stars exploded or shed their outer layers. That enriched gas seeded new clouds, which collapsed into new stars and planets. You are made of recycled star, processed through generations. Every nebula is both a graveyard and a nursery, and the line between them is matter passing through. Type Ia supernovae explode with such consistent brightness that astronomers use them as cosmic measuring sticks. The reason lies in their trigger. Each begins as a white dwarf that pulls matter from a companion until it nears that universal mass ceiling. Reaching the same critical point, the stars detonate with nearly the same energy every time. Because we know their true brightness, comparing it to how faint they appear reveals their distance, letting us map the scale of the universe. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratio's chosen so the wheels turn at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the